So at this point in the course, if you cannot find the derivative of this piece, uh, I don't want to be ugly, but we teach this class again. I got a feeling you'll be back. Um, that's straight power rule, right? Like just, I mean, I don't think anybody would have any problem saying, dy dx is 6x plus 5. We agree on that? Now, as it relates to the next one, that's not a situation where if you can't do it, we teach this class again next term, because you really kind of haven't seen it look like that, right? In order for you to do that, what would be your first thought? Try to get y by itself. Do we agree? And so in order to get the y by itself, you would simply have to move all of this, right? This would become negative 8x squared. This would become positive 2x. This would become plus 4. Do we agree? So what you would do is transform this what you would do is make this y equals, and then you would go fractions, yeah? So you would get 8/3. It'd actually be negative, would it not? Negative 8/3 x squared minus 2x, or 2/3 x, right? Plus 4/3, yes. And then once you do that, once you get y by itself, then you would go ahead and apply the power rule. And so what you would get is negative 16/3 x. Instead of doing the fractions, I'm just going to do it like that for the purposes of our discussion. Minus 2/3. Do we agree? So that's not so bad. We would solve for y. I want to talk to you about implicit differentiation, which would be we don't go through this process. We take the derivative of this piece the way it sits. All right? So let's look at what that piece would be. Well, what we would get is the derivative of 8x squared is 16x. We've already established that. Right? The derivative of 2x is 2. The derivative of 4 is 0, right? We wouldn't do anything with that. And then the derivative of 3y. Now, this is where it starts getting difficult. Because when you take the derivative of 3y, if that were 3x, you would just call it 3. Does that make sense? But it's not 3x, it's 3y. So what we're going to do is we're going to call that 3. We're going to almost pretend like we're taking it with respect to x. We're going to basically just say it's 3. But we're going to put in dy dx because the letter we're taking the derivative of is not an x. So I'm putting it as dy dx right here. Okay? And this is equal to derivative of 0 is 0, yes? So this piece here, 2 plus 0 is simply 2, right? Now, what I have is 16x plus 2 plus 3 dy dx equals 0. How do I solve for dy dx? How do I solve for this piece? How do I solve for this piece? How do I solve for that? Step 1 would be what? Do what? All right, so subtract the 16x. So you would get 3. Jerk. You would get, solving for dy dx, you would get negative 16x. Well, let's do it this way. 3 dy dx equals negative 16x minus 2. Do we agree? Now, how do you solve for dy dx? Divide everything by 3, which would yield you your final result of negative 16 thirds x minus 2 thirds, which you'll see is what we have here. Okay? And so this is what we call implicit differentiation. The process that says, let's not solve for y, let's just deal with it the way it is what we call implicit differentiation. And it's what allows us to, and I'll do another example with you, to do problems like this. 8x squared plus 5x plus 3y squared plus 2y equals 7, for example. And we're going to find dy dx. Okay? So I'm going to work this one with you, and then I'll give you an example to try on your own, okay? So how do I do this if I'm going to solve this for dy dx? Here's what I do. I take the derivative of each piece. So the derivative of the 8x squared is 16x. Yes? Derivative of 5x is 5. Now again, notice that I'm not applying the dy dx here because those are already x's, so I'm good with that. Where I apply that dy dx is on my next piece, right? So we're gonna, I'm gonna copy and paste this thing because that's my new favorite term, copy and paste. All right. 3y squared is going to be 6y, but because the letter is not an x, I'm going to go ahead and apply that dy dx there. Does that make sense? Now, the derivative of 2y is 2, but because I don't have an x, I'm going to apply that dy dx there. Does that make sense? The derivative of 7 is 0, and people will say, do I have to apply the dy dx to that? Well, sure, go ahead. And then 0 times that is 0. All right? Now, how do I solve for dy dx? Okay, so we got to get them on the same side by themselves. So we got this piece. Can't add them together, they're not like terms. Okay. If this were 6y and 2y, you could. Oh, yeah. Not like terms, so you can't add those together. But this side is equal to what? Move this over, move the 5 over, yes? Yeah. So negative 16x minus 5. All right? Now, how do I solve for dy dx? Factor 6y plus, oh, you jerk. Six y plus 2 equals this. All right. Divide by 6y plus 2. Does everybody see what I'm saying? We're solving for dy dx. Divide by 6y plus 2. And that will give you your final answer of dy dx is equal to, screw it, I don't care, negative 16x minus 5 over 6y plus 2. I say I don't care, but I totally care. All right. make that a little bit bigger so you can see it. Everybody got the idea? Piece of cake if you know the answers.
So the y stays around just because it's squared and not just because there's a y.
Right. That's right. The y here in the answer stays there because of. So here's what we're going to do. We're going to go example 2. We're going to go 3x squared plus 8x minus 4y squared plus 2y equals 6. We're going to do two things. A, we're going to find dy dx. And B, we will find the slope of the tangent line at the point, let me just make up one here. Oh, Jesus Christ, that's a lot harder than I thought. We're going to change that to 16, and we're going to find the slope of the tangent line at 2, 2. What's that?
You can edit that part out.
That's good enough, though. I mean, the 16 is not really affecting anything. And I believe if we plug in 2, 2, that actually works. All right? So there you go. There's your problems. We're going to pause this for station identification. You are listening to Westwood One Sports coverage of the NCAA Final Four.
Then you probably have to plug it into that answer. That's what
Yeah,
you have to do.
that's exactly what you're supposed to do. All right, so the observation that was just made was, I bet if you find A, all you got to do is plug 2, 2 into that, and then you'll get B. And the answer to that is, of course, that's exactly what you're supposed to do. Find dy dx, and remember that dy dx is the slope of the tangent line. All right, like that's what that means. And no smart aleck comment from me about anything. Sometimes we forget. We get so engrossed in finding it that we forget actually what we're finding. And dy dx is simply the slope of the tangent line at any given point. So how do you find dy dx? That will use implicit differentiation. This is 6x plus 8. Do we agree?
Yes.
Minus 8y. And then that's where the dy dx will come from. Plus 2 dy dx equals equals 0. Do we agree? I'm giving up on the whole black thing. I wish I hadn't even started the dumb thing now. All right. So what's dy dx equal to? Dy dx dy dx is equal to the negative 6x plus minus 8 goes to the other side. Do we agree on that? Then on this side, the negative 8y plus 2, that dy dx will factor out. And so what you're going to end up doing is dividing this by negative 8y plus 2. Do we agree? Now, from there, that's part A. That's part A. Move this, factor out the dy dx. You'll get, you know what, let me show that intermediate step, please. Because Lord knows if I don't show it, somebody will get confused. Because it's not so easy to see in your head that it's just obvious. All right, so you got that. Now you're factoring out the dy dx. Now you're factoring out the dy dx. And you're getting negative 8y plus 2 equals that negative 6x minus 8. And then you're dividing by that 8y minus 2. All right, and hopefully that might make it a little more clear. All right, so now, once you do that, how do you find the slope of the tangent line at 2, 2? Well, the slope of the tangent line at 2, 2 then becomes dy dx equals negative 6 times 2, that's the x value, minus 8 over negative 8 times 2, that's the y value, plus 2. So negative 6 times 2 is negative 12. Negative 12 minus 8 is negative 20. Negative 8 over 2 is negative 16. Plus 2 is negative 14, which would be equal to 10 over 7. Right?
I got it right. Well, I did it way harder way. I plugged in the whole equation.
Which is equal to 1.428. 5,
That's pretty precise.
7, 1. I have no idea what that is. I was just putting down
That's probably
decimals.
close.
Oh.
Probably.
You're actually thinking about it.
4. I don't know. Let's see what it is. Not just out of curiosity now.
You probably got it like right off.
I gotta calculate all of it.
Oh my gosh, how did you do that? Oh,
What did I say it was?
you said, I think,
Everything
almost
was
exactly
a
that,
one.
dude.
Everything.
Dude, you had the first 4 letters, first 4 numbers,
Right,
right? How the heck?
Oh, all of them.
Wait. No
Hey,
way.
you doing it?
No way.
All right.
That's impossible.
Anyway, the many math tricks of the teacher. All right. So, anyway, that's dy dx. Any questions on implicit differentiation? All right. Join me next time.